Which year is penultimate year? Which year is called as penultimate year? Which year is called as penultimate year? अरे बताओ. What were we doing? Triangles. Write the first question. In a triangle ABC, BA is produced to E. BA is produced to E. Whereas AC equal to BC equals to AD. Whereas AC equals to BC equals to AD. And BC produced to D. And BC produced to D. Full stop. Angle EAD equals to 93 degree. Find angle BDA. Find angle BDA. In a triangle ABC, BA is produced to E. BA is produced to E, whereas AC equals to BC equals to AD, and BC produced to D, and BC produced to D. Angle EAD equals to 93. Find angle BDA. Find angle BDA. What is the answer? Done. AC equals to BC equals to AD, angle 30, 23.5, 43, no, show me the resistance. Okay, look at the board now. In a triangle ABC, so this is triangle ABC. A, B, C, BC produced to D, so this is D, and BA produced to E, so this is produced to E, so this is E. Okay, and the next thing is AC, this AC equals to BC equals to BC equals to AD. It means these three sides are equal. Okay, it means these three sides are equal. Okay, angle EAD, that EAD, this angle is given as 93 degree, and we have to find out that angle BDA, it means this angle. Is this understood by you now? Okay, let's understand what we can do. If this angle is angle A, so this angle has to be angle A or not, because this is isosceles triangle. So if these two sides are equal, so the opposite angles must be equal. Okay, so this A, this A. If I talk about this angle, this one, what it will be? It will be A plus A. Exterior, sum of two interior angles will be equal to the exterior opposite angle or not. So this is A plus A, that is 2A. And if this angle is 2A, this angle has to be 2A or not, because in this triangle ACD, AC equals to AD. So if the in front opposite to this side there is 2A, so opposite to the equal side there must be 2A or not. Getting it now? Okay, and we have to find out the value of 2A. We have to find out the value of 2A because this is BDA. Got it? Now we can apply the same thing here. This A and this 2A, after adding, it will be equal to 93 or not? Because sum of, in the big triangle ABD, the sum of two interior opposite angle will be equal to the exterior angle. Okay, so I can write it like A plus 2A equals to 93. So 3A equals to 93, or we can say A equals to 31. And 2 into 31 we need, because we need the value of 2A. So the answer is 62. That was very good question. Now you got it. So the answer is 62 degree. Done? Understood by you now? This is very important. They usually ask this type of question. Make a star, because this is really important. And the concept is really simple. The isosceles triangle, first concept. The second concept is sum of two interior angles will be equal to the exterior opposite angles. That's it. Okay. Write the next question, please. If the sides of a triangle ABC, if the sides of a triangle ABC are produced, then find the sum of the exterior angles. Then find the sum of the exterior angles. Done. Find out the sum of the exterior angles now. Good. 360 degrees is the right answer. This is simple one. 360 degree. Double the sum of the internal angles of a triangle. You have to remember it like this. This is the question. Okay. So all the sides are produced. This side has been produced to this, this and this. Or you have to produce the vertex. Okay. So now this is A, B and C. If I name the exterior angles, this is exterior. So this can be X, this is Y and this angle is Z. Okay. I can name this angle as 180 minus X because angle on a straight line. 180 minus Y and 180 minus Z. Okay. And you know one property, that sum of the internal angles of a triangle, they are, the sum of the internal angles of a triangle is 180. So I can write 180 equals to 180. How many times we have 180? 180, 180 and 180. 3 times, or let it be 180 here, right? 180, 180, 180 minus X minus Y and minus Z. Because this is the sum of 3 angles of the triangle and the sum is equal to 180. Okay. So 180 will be cancelled out with 180. Take that X, Y, Z here. So X plus Y plus Z equals to, we have two 180 here. So this is 360. So sum of the exterior angles is equals to 360 degree. Any problem in this? No problem at all. Done? Good. Move to the next one. This is done. Find the value of X. Find the value of X in this figure. Find the value of X in this figure. I'm giving you the options also. Alpha minus beta minus gamma. Alpha plus beta plus gamma. Done? B is the right answer. Alpha plus beta plus gamma is the right answer. Done? No. Look at the board now. We can draw a straight line here. We can draw a straight line here, and we know that this angle will be what? Alpha plus beta. So name this angle as alpha plus beta, and this angle is gamma, and x will be equal to two interior angles, this one and this one, the sum of these two interior angles. So this will be alpha plus beta plus, okay. Write one more question. The side BC of a triangle ABC, the side BC of a triangle ABC is extended to a point D if angle ACD equals to 117 degree and angle ABC equals to 5 by 8 times angle ABC equals to 5 by 8 times of angle BAC, 5 by 8 times of angle BAC. Find angle ABC. Find angle A, B and C. Sorry, ABC. (45). Look at the board. So from here I can write like angle ABC upon angle BAC equals to 5 by 8. Sorry, 8 by 5. 8 by 5. Okay. So I can say this. Let's come to the question. BC is produced to D and this is A. ABC is 8 units. So I'm writing it 8A. And BAC is 5. BAC is 5. उल्टा कर दिया मैंने. ABC equals to this. ABC equals to 5 by 8. Sorry. ABC equals to 5 by 8. ABC equals to this. So ABC upon angle BAC equals to 5 by 8. So in this, angle ABC is 5A and this is 8A. Okay, and ACD is 117 degree. What we have to find out? Angle ABC, it means we have to find out the value of 5A. Okay, so we can add these two angles and it will be equal to 117. Okay, so 13A equals to 117. So A equals to 9 but we have to find out the value of 5a, so it will be 5 into 9, that will be 45 degree. Okay, done. One more and last question on this format. Is this done? This is given and this you have to find out. In this given figure, Cn is angle bisector of angle ACB. Angle ABC is 50 degree, where AN, side AN equals to AP. You have to find the value of angle cap CAP. After that, the next topic is similarity. Done? Okay, look at the board now. As we know, in this triangle, AN equals to AP. So this is AN, this is equal to AP. Okay. So if I name this angle as X, this angle has to be X, because this is isosceles triangle. Okay. One line is there that CN is angle bisector of ACB. So this is ACB and CN. This CN is angle bisector. What is angle bisector? which bisects the angle exactly into two parts. Okay, so if I say that if this part is y, so this part has to be y or not. Okay, any problem in this? What we have to find out? We have to find out cap, let it be theta for some time. So we have to find out the value of theta. Okay, and what is given in the question? This ABC, it is given that 50. Okay, any problem? So in triangle NBC, I can say 50 plus y equals to x or not. Sum of two internal angles will be equal to the exterior angles. Okay, so I can say that 50 plus y equals to x. Any problem in this? No? Okay, let's come to this triangle, that APC, where theta plus y will equal to x. Look in this triangle, this APC, where that theta plus y equals to x. Okay, okay, so write in this, in triangle APC, theta plus y equals to x. And as we know that these two values, 50 plus y and theta plus y, is the value of x. Okay, so we can equate them or not? So we can equate them. 50 plus y equals to theta plus y. Y will be cancelled out, so the value of theta is 50. Okay, are you getting it? Good. Now let's start similarity. Very good topic and important one, and very simple one also. Make a heading, similarity. How we can understand similarity? This is done, everybody? Okay, write it. Start it with the new page, similarity. Have you heard that similar triangles and congruent triangles? So what is the difference between similar triangles and congruent triangles, or similarity and congruency? Have you seen that passport size photos? If you place one photo and above that other photo, then other photo, and if you pile up like this, so obviously if you see the first photo, you will see the same dimension at that time. So you can exactly place one photo over other. So this is congruency. This is congruency because the dimension is really same. The dimension is really same. Okay, I'm not talking about similarity or congruency in triangle. I'm talking about similarity and congruency in generalized form, so that you will have a bigger vision of that. Okay, don't worry, I will make you understand. What is the difference between similarity and congruency? This is a circle. It has the radius as 3. This is a big circle where the radius is 6. Okay, if I want to place exactly a circle on this, so the radius of that circle must be 3 centimeter. Array, just try to visualize. If you want to cram it now, first of all, similarity they ask in the triangles, but I am giving you a bigger vision so that the triangle similarity will be taken care of. Okay, if I want to place another circle of this on this circle, so what will be the radius of that circle? 3 centimeter, obviously. Okay, so I can say if I have the same circle like this, or have you seen this, seen the bangles? You can place the same radius bangles on bangle over bangle, bangle like this. Have you seen that? So this is also a congruency. Okay, Now just try to learn the concept according to the mobile phones. Like we have zoom in and zoom out option in the mobiles. If you want to see a photo, you can zoom in the photo and zoom out the photo. Okay, if I want to, if I minimize this, so at some point it will be of 3 centimeter or not, the radius, and at that point of time it can be placed on this if I minimize it. Okay, so these two circles are similar but not congruent. Okay, getting it? I can maximize this circle also. So if we maximize it at one point, it will be of 6 centimeter or not? It can be. So at that point of time, I can place this circle to over this circle. Okay. So these two circles are similar but not congruent. Are you getting the difference in a broader way? So if exactly you can place anything of the same dimension on over other, that is congruency. And if you minimize or maximize, or if you change the size, not the shape, size, okay, and you can place that particular thing over the other, that will be considered as similarity. And circle is the best best thing to understand, because it has only one dimension, that is radius. Okay, say yes, no please. Okay, getting it? So in congruency, you can write the example of passport size photos so that you will remember it. Write it please. Wait. There are three triangles. Okay. So I can place this triangle through this triangle also, if the angles between them will be equal. We will learn in next one, but I'm just saying it that if I maximize it, I can place this triangle to this triangle, so these two triangles are similar. Okay, if I maximize that one, I can place that triangle to this triangle, so these two triangles are similar, and I can place that triangle to that triangle also, so these three triangles are similar if they have the same angles at that time, because the face opening here, so this face, this face or this face has to be equal. Okay, write some 2 or 3 points on similarity. Write the first point. In similarity, size can be increased or decreased. Size can be increased or decreased, but shape does not change. What he is trying to say, I have, let's say I have one circle also. If I want to place this circle on this triangle, it cannot be placed because these two shapes are totally different. Okay, right, next one. If the length corresponding, if the length corresponding component is k times, is k times, then every corresponding length becomes, then every corresponding length becomes k times. What he is trying to say, if this side is 6, this side is 6, and this side is 6, I am taking equilateral triangle. This is 3, this is 3, and this is 3. So what is k times? if I say this dimension and this dimension, this is double of it, so this is the value of k here, k times. Okay, so he is saying that other corresponding length must be magnified in the same way. So if I multiply it by 2, it will be 6, and multiply it by 2, it will be 6. So I cannot increase only one side. Getting it? I cannot make this 6, because if I am going to place on this, so this side will be totally covered, but the other sides are 3 and 3, so it will not cover it totally. Okay, getting it? Okay, right, the last one, you can magnify the smaller one, you can magnify the smaller one, and can diminish the larger at one point, and can diminish the larger one, and can diminish the larger one at one point, it will superimpose the bigger and smaller one respectively, the bigger and smaller one respectively. Okay, now let's try to apply similarity in the triangles. The question is, write the question. The question is, can two scalene triangles be similar or not? Can two scalene triangles be similar or not? This is the question. Always. What is scalene triangle? It was not expected from you. So can be similar. Always. First of all, my question is, can be similar or not? And the second question is, always or can be sometimes. Okay, I'm making two similar triangles. Sorry, two scalene triangles. This is 3, 5 and 6. This is 6, 10 and 12. The condition in scalene triangle that the length of the sides in scalene triangle, they all are different. So this is a scalene triangle, and this is also a scalene triangle where the lengths are 3, 5, 6 and 6, 10, 12 respectively. Okay, let's check the k factor. If I multiply this 3 to this, 3 to 6, 5 into 2, so here the k factor is 2. So for whole triangle there must be the k factor as 2, and if I multiply it by 6 into 2, it is 12. So definitely these two triangles are similar triangles. Okay, now let me make some change. This is 11. This is 11 now. Now tell me if these two triangles are similar. No. Why? Because we have k factor as 2 in two sides, but if I am going to multiply it by 2, it will be 12, but here the length is 11. These two triangles are scalene triangles and are not similar triangles. Getting it now? So K factor must be equal. If you want to understand it like in a deeper way, just take two equilateral triangles so that everything will be cleared. Okay, got it now? So your answer is can be similar but not always. Can be similar but not always. Write the answer. Second question is, can two right angle triangle always be similar? Always be similar. Can two right angle triangles always be similar? Okay, I am making two right angle triangles. 6, 8, 10. Okay. 15, 8, 17. Now we have to check the K factor. Here we know that this is 8 and this is 8. So according to this, K factor is 1 here. K factor is 1. So if I multiply this 6 into 1, it will be 6. But there is no side such as 6 there. Okay. And but both the triangles are right angle triangle. Both the triangles are right angle triangle. So we can say they can be similar or cannot be similar. Okay. They can be similar or cannot be similar. Not in this case, they are not similar. They are not similar. But what if I take the sides? Is this understood by you? And we have one common side also, that same length, 8 and 8. And both are triplet, 15, 8, 17 and 6, 8, 10. Okay. Let me change the sides. If this is 3, 4 and 5. Now tell me, are they similar? Yes, they are similar. And the K factor is 2. 2 and 2. Okay? Understood now? Any problem in this? No? Now let me make it more simple. Can two equilateral triangle be similar always or not? Good. Two equilateral triangles will always be similar. Will always be similar. Why? Because they have only one dimension. Now you are going to say it will have three sides, but the length of these three sides is equal. See, so they will always be similar. So this is like 3, 3 and 3, and I'm taking it or if you don't want to take the multiple, don't take multiple. Let it be 4, 4 and 4. So what will be the K factor here? K factor is 4 by 3. K factor is 4 by 3. For this it is also 4 by 3, and for this it is also 4 by 3. So we are getting K factor as same. So take any value, but two equilateral triangles will always be similar. Got it now? Any problem? No? Okay. Write one question. ABC is an equilateral triangle. ABC is an equilateral triangle and MN is parallel to the base BC. MN is parallel to the base BC. If the ratio of MN is to BC, if the ratio of MN is to BC is equals to 4:11, then find the length of AM. Then find the length of AM if the length of AC is 22 centimeter. If the length of AC is 22 centimeter. Done? Look at the board, please. Forget this question for some time. Just try to understand one concept. And just try to understand this concept by cross sections which can be made. So this ABC is an equilateral triangle. I'm drawing a line parallel to the base. This is MN. This line is MN, and which is parallel to the base. Which is parallel to the base. I'm not talking about question right now. I'm just telling you what can happen. As we know that this section and this section where we took the cut, that will be equal because the lines are parallel. If you want to imagine it like this, so make it an equilateral triangle and just try to cut it from the base parallel to the base. So you will exactly take this section. So definitely this length, this BM will be equal to CN, because both MN and BC, they are parallel. So what I'm trying to say is this triangle ABC is equilateral triangle. So triangle AMN will also be equilateral triangle. Okay. I'm taking another cut which is parallel to that base BC. So this, now the triangle is APQ. Whether APQ will be equilateral triangle or not? Definitely. So in a equilateral triangle, if you take any parallel side, so that triangle will also be the equilateral triangle. I'm taking one more and let it be LT. So ALT will be equilateral triangle or not? Yes, just try to apply this property in this question. Just try to apply this property. Done? What is the answer? 8. Good. Now look at the question. This is ABC. MN is parallel to BC, the ratio of MN and BC is 4 is to 11. So MN 4 and is 11. Okay. Okay. Look at the board, please. And as we know that AMN and ABC, they all are what? Equilateral triangle. Okay. And if you don't understand it like this now, understand it with the concept of parallel lines. If this is this angle theta, this angle is theta, and this angle is theta, because ABC is an equilateral triangle, it is given. This one inside and one outside angle theta, and one inside one outside theta. Okay. So if this length is 4 unit, this has to be 4 and this has to be 4 or not. Okay. And this whole length must be 11, and this length must be 11, and this length is 11. It is given. Okay. So what is given in the question? BC is given. So if BC is what? 11 units. So the value of 11 units equals to 22, and we have to find out AM. AM is what? 4. Okay. So we have to find out the value of 4 units. So it is 22 by 11, or the value of one unit is 2. Multiply it by 4. After multiplying it, we are getting 8. So the answer is 8 centimeter. Are you getting this concept? Okay. If this length is 4, so AMN is an equilateral triangle. So this has to be 4, this has to be 4, because all the sides are equal. And this length is 11 units. Value of these 11 units is given as 22. So value of 1 unit will be what? 11 into 2, 22. So we have to find this one. 4 into 2, that is 8. Okay. Got it? Write the property angle, 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 angle. Tell me if these two triangles are similar. You can understand it like with the open mouth of a line or something. It will make this angle. So I want to place the other my concept is very similar. Again, I just want to place this triangle on this triangle, or whether this triangle on this triangle. Okay, so how can I place? Here we have that 65 degrees. So this 65 degree can be placed on this 65 degree, and this 55 can be placed on this, and this 60 can be placed on 60. So it can be placed. If it is possible to place or superimpose the other figure, so definitely they are similar. That's it. That's the main point. If you are able to superimpose the other figure, so they are similar. Okay. Here what we are using angles. We are using angles. That's why this is angle, angle, and angle property. Okay. Any problem in this? You have to remember one thing only, that superimposition after magnifying or diminishing. That's it. That is very simple. Okay. Just give me one, just tell me one thing now. Are they similar now? They cannot be imposed. So we cannot impose that triangle on that one or this triangle to that one. So they are not similar. Getting it? Any problem in this? No problem. Okay. Tell me, are they similar now? Yes. Array, if two angles of any two triangles are equal, then obviously the third angle will always be equal. Okay. So these two triangles are similar. Again, getting it? Write the last property SAS, side angle side. Side angle side. SAS. Are these two triangles are similar? Similar. This side 3 to 6. So k factor is 2. And the angle between, so this 4 and this is 8. So the k factor is 2. Now the next thing is, if we don't have the similar k factor for this, we can check the angle also. Okay. Now angle between these two sides is 70 and angle between these two sides is also 70. So this is side angle side. Okay. So you will have the same opening. I'm talking about angles. Same opening. Okay. If this angle is 79 degree, will they be similar? No, because obviously that k factor is same, but we don't have the similar angle or we don't have the same angle. Here if I want to place it now, it will be like somewhat like this. Okay, so we cannot superimpose it. Okay, getting it? Shall we move to the next one? Okay. So write one property, very simple one. So in similarity, what we can derive, it is very simple that I can write AB upon PQ. So I will get this ratio of the sides. So we have three sides, so I can write like AC upon PR and BC upon QR. Once, see what is the meaning of it? What is the meaning of it? Once I get the ratio of one side na, so definitely for the whole triangle it will be same, as we know that the k factor. Okay, Write it in your notebooks of the heights and yes. Then perimeter 1, perimeter 2, median 1, median 2, and altitude 1, altitude 2, height 1, height 2, and the last one is AB upon PQ square, that is area. If we square it, I will get the ratio of their area. Square any of the dimensions. Okay. Just remember the concept that we used in cone when we took a cross section there. So we used height in that question. Height. If I square the ratio of the height, I will get the ratio of their area. Okay. If I square the ratio of their medians, I will get the ratio of their area. Okay. If I square the ratio of their perimeter, then I will get the ratio of their area. Okay. And one more thing, that if I write it like this, if I underroot it, I will get the ratio of these all things. This is very important. This is the conclusion of similarity. Okay. And they will ask from here only. They are not going to ask A or SAS. They are going to ask from here. And a lot of questions they will ask. Okay, understood now? So once we have any of the ratios, like ratio of their height, ratio of their perimeter, ratio of their medians, ratio of their altitudes, ratio of their any of the sides, we can find the ratio of their areas. Okay, after squaring it. Got it? And what is area? Area is the product of two dimensions. Area is the product of two dimensions. How I'm saying it? Let's take a square. Square has two sides. That base. If I take length and breadth, they have same length. Like A. So A into A square. So this is in very simple form. We can say product of two dimensions is area, and product of three dimensions is volume. Just try to think in a broader way. Don't cram it. Like, it is very simple. Understood now? Okay. Triangle ABC and triangle PQR. Triangle ABC and triangle PQR are similar. PQR are similar. If the ratio of their perpendicular, is 3:4 respectively, then find the ratio of the areas of the triangles. Make a star on this question. They just ask these type of questions in Excel. So the area ratio is 9:16. So this is triangle ABC, or you don't have to make it in the exam. You don't have to make it. Why? Because I know that the ratio of their perpendicular. So I can write it like AB and that PQ, sorry. PQ equals to 3 by 4, and if I square it I will get the ratio of their area, so it is 9 is to 60. 9 is to 60. Okay, any problem in this? Write one more question please. Triangle ABC is similar to PQR. Triangle ABC is similar to triangle PQR if the length of AB is 4 centimeter. If the length of AB is 4 centimeter, BC is 9 centimeter, BC is 9 centimeter, and AC is 7 centimeter, and AC is 7 centimeter. Full stop. If the length of QR is 21 centimeter, if the length of QR is 21 centimeter, then find the length of QP and PR. Then find the length of QP and PR. Done? QP is good. PR 27. Good. Look at the board. This is ABC. 4, 7 and 9 is given. Now read the question. If the length of the AB 4 centimeter, BC 9 and AC is this. If the length of QR is 21 centimeter. So length of QR. And he has said simply that both the triangles are similar. Both the triangles are similar. And in similarity, which triangles are similar? ABC and PQR. Okay. Triangle ABC is similar to triangle PQR. Okay. In this, how you can write it? How you can write it? Like I can take these two sides. So AB upon PQ. Then I can take these two sides. Okay. I can write BC upon QR, and then two extreme sides AC. And here we have that extreme sides. Okay. Let's come to the question. Here we have that AC, and here we have that PR. Wait a second. 7 into 3, that is 21. So it must be 4 into 3, 12, and 9 into 3, 27. Wait. ABC is similar to QPR. What I said? PQR. Correct it. Sorry. Correct it. ABC is similar to QPR. ABC is similar to QPR. Sorry. So we have to change now. So here we will have that first that QP, then BCPR and ACQR. Okay, and the length of QR is given, that is 21 centimeters. Now we are getting it. Have you understood this method of writing? Take first two, then next two, then next two, and then after that takes the extreme most. And if you want to compare the angles, then angle A will be equal to angle Q, B will equal to P, and C will equal to R. So with the help of this, you don't have to make the diagram. Okay. So this 7 into 3, that is 21. BC has the relation with PR, so this PR must be 9 into 3, that is 27. And AB has the relation with QP or PQ, so 4 into 3, that will be 12. So the answer is 12 and 27. QP is 12 and PR is 27. Got it? Any problem? Okay, good. In the given figure, right, in the given figure, MN is parallel to PQ, MN equal to 4, QR equal to 8, PR equal to 6. Find P and find Pn. So this is the figure. PQR and this is Mn. P is the right answer. Look at the board. Mn is 4 and this QR is 8 and what is given on that PR. This PR is 6, but we don't need that PR here, as this angle is, as if this angle is theta, this angle is theta. If this angle is Y, this angle is Y, and angle P is common in both the triangles PMN and PQR. So we can say that PMN is similar to PQR. If the triangles are similar, so we can take the ratios also. Okay, what we have to find out? We have to find out Pn, this Pn. So I can take the sides. I'm taking two triangles. In triangle, smaller one, that PMN, and triangle PQR. My suggestion is very simple, that we will take the take that side first, which we have to find out. Okay, so what we have to find out in this question? Pn. So in small triangle PMN, in front of this theta there is Pn. In the bigger triangle, in front of this theta, what is there? PR, and the length of PR is 6. In the smaller triangle, in front or opposite to angle P, what is the length here? That is Mn. Okay, Mn is 4. In the bigger triangle PQR, opposite to P, there is length, that QR, and the length QR is 8. 4, 2, 2, 3. So length Pn is 3 centimeter. This is the proper way to do. Okay. So suggestion is very simple, that what we have to find out, you have to take that side first, so that you will not forget what we have to find out. Okay? Are say yes, no? Done? One more question. Where triangle ABC similar to triangle PQR, find angle ACB. 70. So the right answer is 70. See, angle A will equal to angle P, angle B equal to Q, and angle C equal to R. Angle A 47, so this has to be 47. Okay. Angle Q is 63, so B has to be 63. Okay. Now we have two angles in the triangle, 63 plus 7, 70 plus 40. So this angle is 70. And if angle C is 70, angle R has to be 70 also. Okay. Got it. Now let's move to the next one. Now start basic proportionate theorem, BPT. Basic proportionate theorem, BPT. Okay. In this, MN is parallel to BC. So write some results. We can write it directly. This length x upon y equals to that A upon B. X upon y equals to A upon B. Okay. And if you don't want to cancel, then this is first one. Second one, I can write x upon the whole length, that P. Okay. So here we have to take A upon Q. This is second result. And the last one is, we can take this also, this section. So y upon the whole length P, and B upon the whole length Q. So this is basic proportionate theorem where Mn is parallel to Bc. Where Mn is parallel to Bc. Write one question based on it. Write it in your notebooks. Done? Write a question. In the given triangle, Mn is parallel to BC. Mn is parallel to BC. Find the length of BC. Find the length of BC. Find the length of BC. Twelve. 12 is the right answer. So in this Mn is parallel to that BC, we have to find out the length of BC. BC length is 3x. Once we get the value of x, we will get the value of BC. And the length value of x is 4. How? As we know that we can take x upon x minus 2 equals to x plus 2 upon x minus 1. We can take, in the next step we can cross multiply it. So multiply this x by with this one. So this is x square minus x equals to x square plus 2x minus 2x and minus 4. So this is cancelled out, this is cancelled out, this minus and minus cancelled out. So the value of x is 4. Okay, and we have to find out the value of 3x. So 3 into 4 equals to 12. 3 into 4 equals to 12. Okay, do cross multiplication there. Area of triangle PQR is 144 centimeter square. Area of triangle PQR is 144 centimeter square. Find the area of triangle ABC. Find the area of triangle ABC. If AB upon PQ, if AB upon PQ equals to 2 by 3, AB upon PQ equals to 2 by 3, and both the triangles are similar, and both the triangles are similar. Area 64. Square करना. 64 is the right answer. Look at the board. This is the ratio of their sides. This is the ratio of their sides, and both the triangles are similar. So if I square it, I will get the ratio of their area or not. Okay. So what it will be? 4 by 9. And what is given? Area of triangle PQR. It means PQR. So PQR area is 9 units, and that area of ABC is 4 units. So we have to find out the value of 4 units, and 9 units is given in the question. Okay, so the value of 9 units is 144. So if I multiply, so it will be 116. Okay, so 16 into 4 will be 64. That's it. Okay, because the value of 1 unit is 16, we have to find out the value of 4 units for there. So the answer is 64. Now let's start centers of triangles. Centers of triangles. Important topic. There are 4 centers of triangles. Centers of triangles. Very important topic. First one is in center. In center. In center, or write it in the bracket, internal angle bisector. Write it in a bracket. Sometimes they directly ask this thing, that internal angle bisector, or sometimes we usually forget what is the application of that in center. Okay, so in center is internal angle bisector. Now make a triangle. And this intersection point, name it as I. Usually they denote in center as I. Okay, so in this triangle, AD, BE and CF, they are angle bisectors. AD, this AD, okay, this BE and CF, they are angle bisectors. And the intersection point of these angle bisectors is in center. The intersection point of these angle bisectors is known as in center. Got it? So AD is the angle bisector for what? Which angle? AD is the angle bisector for what? For which angle? Sorry. Angle BAC. Angle BAC. Okay. BE is the angle bisector for which angle? ABC. And CF is the angle bisector for which angle? ACB. Okay. Any problem in this? And the intersection point is known as in center. Got it? So if this is in center, so if I draw a circle there, this is in circle, this is in circle. Look at the board, and this is the center, and you know it very well. The property is very simple, that from the center to the circumference, if we take a straight line, it will be the radius. So if I take this one, this is radius or not? So this is radius or not? This IE, and this IF is also the radius. Got it? Any problem in this? So I can say that this ID equals to I, E equals to I, F equals to, in radius, isn't it? So I can say the length of ID, IE, IF is equal to the radius of the in circle. Okay, this circle is inside the triangle, that's why we are saying it in circle. When the circle will be outside the triangle, it will be the circumcircle. Okay, are say yes, no, ladies and gentlemen. Write one note, NOTE. The in center of the triangle, the in center of the triangle is equidistance, from all the three sides, is equidistance from all the three sides of the triangle, and the distance is equal to the radius, and the distance is equal to the radius. And the distance is equal to the radius. Okay, now let's try to understand this thing. He is saying that this center is equidistant from all the sides. So this is the side here, and if I have to go to this distance, I have to travel this. It means I have to travel r. From this side, if I want to go to this center, I have to travel again r, and if I want to go to this side, so I have to travel r. That's why it is equidistant from all the sides. So usually they ask this in theory. Okay, and they will give you the option in center, circumcenter, and will give you this line, which center is equidistant from the sides. Then your answer will be in center. Okay, so they ask this type of question in the theory part. Now is this understood by you? Any problem in this? Okay, so you have to remember two things. First one is that the in center is equidistant from the sides, and the second, the main thing is it is internal angle bisector. How it works? If I say this angle is y, so this angle has to be y or not? If this angle is x, this angle has to be x or not? If this angle is theta, this angle has to be theta. Okay, any problem in this? Tell me, any problem? No problem. Okay, let's move to the next question. So write its third property, very simple one. Let me remove this. Write this one, angle BIC, this one, angle BIC equals to 90 plus half of A. This is important one. 90 plus half of A. Half of this A. It means opposite to this only. Okay. Now you have to tell me the next one. If I say that angle AIC, what it will be? Angle AIC, what it will be? 90 plus half of B. Now we have to find this one, na? So opposite to this is B. So this will be 90 plus half of B. And the third one is left, that is AIB. So AIC and BIC. Yes, so yes, AIB. What it will be? This angle, this one. 90 plus half of C. This is the most important thing for incentive. This is the most important thing. They ask the question directly. You have to put that formula, that's it. And if you want to remember it, it will be very easy, because this I is the in center. We have that BC here, BC. What is not here? So half of it. Okay. See, AC here. We have that AC. What is not here? B, half of B. Okay. AB is here. What is not here? C, half of it. But 90, you have to remember that 90 plus 90 plus 90 plus. Okay. Any problem? No. Okay. So these are internal angle bisectors. So sometimes they give the external angle bisectors also. Sometimes in some questions they usually give the external angle bisectors also. So let me make that external angle bisector. Is this written by you, everyone? Okay. So A, B, C. So let it be O or something. Take. Okay. Now in this, angle B and angle C are external bisectors. So I can write this X. So this can be YY. External bisectors, not internal. Okay, external angle bisectors. So in this case, the value of BOC will be 90 minus half of A. 90 minus half of A. Okay. Write one question now. In a triangle ABC, angle A is equal to 58 degree. Angle A is equal to 58 degree. If I is the in center of the triangle, then find the measure of angle BIC. In triangle ABC, angle A equals to 58 degree. If I is the in center of the triangle, then find the measure of angle BIC. 119. Good. 119 is the right answer. So I can write this BIC. I know that here we don't have that A. So I can add it directly. 90 plus 58 by 2. So the answer is 119. That's it. Okay, good. So write the next thing in radius of any triangle. In radius of any triangle. So by using this formula we can find in radius of any triangle. Okay, in radius, so I'm writing in radius with small r, in radius of any triangle, that is delta upon s, that is delta upon s, where delta is area of triangle. Write it, delta is area of triangle, and s is semi perimeter. Semi perimeter of triangle. S is semi perimeter of triangle. Okay, so by using this formula delta by s we can find the in radius of any triangle, whether it is equilateral, isosceles, right angle triangle, whatever. Okay, so this is universal formula for finding in radius in any triangle. This is very important. Sometimes they ask directly or sometimes they give the questions. Right, one question based on it. The sides of a triangle are 3, 4 and 5 centimeter. 3, 4 and 5 centimeter. Find the in radius of the triangle. Find the in radius of the triangle. Done? What is the answer? Good. 1 is the right answer. Okay, look at the board. Sides are 3, 4, 5. So this is 3, 4, 5. As we know, this is right angle triangle. As we know, this is right angle triangle. Okay. So I can draw it like this: 3, 4 and 5. So what will be the area of this? Half into 3 into 4. Area of this triangle is half into 3 into 4. That will be 6. What is semi perimeter? We first of all I have to take perimeter and divide it by 2. That will be semi perimeter. So the perimeter is 3 plus 4 plus 5 upon 2. So this is 12. So this is also 6. And what we have, the delta upon s, so it will be 6 by 6. So the answer is 1. So the answer is 1. Okay. So it can be used to find any of the in radius. Now write the next thing. In radius in right angle triangle. In radius in right angle triangle. You will find these things in your exam directly. In radius in right angle triangle. कृष्णा मैम चाय वाय पिला दो, 3 घंटे हो गए बोलते हैं, मतलब फैकल्टी का तो कोई वो ही नहीं है भाई, बिल्कुल हद होगी. इन रेडियस इन राइट एंगल, नहीं मैडम मैं नहीं पीऊंगा. In radius in right angle triangle. So this is perpendicular, this is base, and this is hypotenuse. So this is in radius small r. So it is P plus B minus H upon 2. P plus B minus H upon 2. हाँ मैडम. करा लो, और इनका सर्कल का टॉपिक रहता है, फिर वो वीकेंड पे करूँगा मैं। हाँ मैडम, बहुत हिम्मत कर रही है। अरे यार दिनेश सर यार, तो दिनेश सर के लिए केक मंगाओ और क्या। मैं वीकेंड पे कराऊंगा सर्कल रहे, सर्कल रहे मैडम, तो मैं कंसेप्ट ही करा रहा हूँ बस। हाँ तो क्वेश्चन नहीं करा रहा। अरे तो वो तो हिंदी है सर, ये तो वो ऑन ऑफ वाला भी नहीं है, ये तो ग्रीन भी गया तो ऑन है। And we are getting the same answer. So hence proved that formula can be applicable in any of the triangles. Okay, so let's take the side that 3, 4 and 5. So it is 3 plus 4 minus 5 upon 2. So 7 minus 5, that is 2. So 2 by 2, that is 1. Okay, so we are getting the same answer. Now let's move to what happened in radius of equilateral triangle. Is everything okay, or I did some mistake? In radius of equilateral triangle, height of equilateral triangle is root 3 by 2a. So height of equilateral triangle is root 3 by 2a. What is the area? You can say that area is half into base into height, or you can write it directly now because you have learned it, root 3 by 4a square. Or if you don't remember it, you have to remember it first of all. Root 3 by 4 a square. And how it came? It is half into base into height. Half into base into height. So write in radius and write circumradius also. So in radius is a by 2 root 3 and circumradius is a by root 3. Okay. In radius is a by 2 root 3 and circumradius is a by root 3. and sometimes they ask the ratio of in radius and circumradius of a equilateral triangle, then what it will be? 1:2. 1:2. How? This is a by 2 root 3 and this is a by root 3. Cancel this, so it will be 1:2. 1:2. So from here you can derive one thing, that the outer radius or the circumradius is exactly double of the in radius in equilateral triangle. In equilateral triangle. Okay, any problem? No problem. Good. Write the questions. If the sides of an equilateral triangle is 16 root 3, find the difference between the circumradius and in radius. हेलो सर, बढ़िया, आप बताएं। सर अभी ये 6 बजे तक है, क्लास में ही हूँ मैं। ठीक है सर। if the side of an equilateral triangle is 16 root 3, find the difference between circumradius and in radius. Find the difference between circumradius and in radius. Circumradius is outside the triangle. Done. Eight is the right answer. Look at the board, please. In radius will be what? A by 2 root 3. So A is 16 root 3 and this is upon 2 root 3. So in radius is 8. R 16 root 3 A by root 3 it means. So this is 16. So what is the difference between these two? 8. What is the difference between these two? 8. Any problem? In the same question, just give me the answer. What is the difference between the area of circumcircle and incircle?